Good afternoon to all the audience and the esteemed speakers. I would like to welcome you all to the Tech Talk session being conducted by SolutionBuggy. And today we'll be looking at opportunities in the chemical sector. Uh, our morning session, we had looked at uh, within the chemical sector, we had looked at specialty chemicals and chemicals in the food processing area. And now we will be looking mainly at the construction chemicals and a few chemicals which are basically methanol based. Chemicals which are in green methanol, or it could be green hydrogen, and also in the manufacture and which are used in the manufacture of steel and cement, and also in the transportation sector. Uh, the sector, I think, the chemical sector as such has been drawing a lot of interest from new entrepreneurs wanting to get into it, especially in specialty chemicals and agrochemicals, construction chemicals, and the new chemicals which are required for either in the biofuel sector and things like that. And also, the government has been very instrumental in this. One is obviously the ban on import of a lot of chemicals from China, and very good incentives ranging right from 50 lakhs to almost up to 4 crores for setting up of chemical based industries. Also, the demand has been huge in the domestic as well as in the exports market, especially from Middle East and Europe for green chemicals. So today in this second session, like I mentioned, we will be looking at construction and methanol-based chemicals, where we have two experts who will, over the next 90 minutes, walk us through the different segments in these chemicals, what kind of manufacturing process is involved, what is the product development and formulation that is required for setting up an industry in these areas. Just to give an introduction of what we do at SolutionBuggy, we are an online platform where we connect the manufacturing industries to the experts. We have completed more than 3,100 projects over the last 6 years. On the platform, we have 10,000 plus experts, and the projects can range anywhere between a one-day consulting assignment to entire plant setup, which can go beyond a year. So we start right from concept to commercialization stage, which includes basic market research, product identification, detailed project report, machinery procurement, plant setup, commissioning, and to some extent even in the sales and marketing, market development also. Currently, we are doing a few projects in the chemical sector where we are working on new product formulation and getting some certifications on a few molecules as well. With that, I would like to introduce the panel today. I am Guru Prasad Bangle, director and director at SolutionBuggy. I have about 20 plus years of experience in the consulting sector. I am an BE and an MBA from IIM Bangalore, and I handle new projects and project management at SolutionBuggy. I have two stellar speakers with me. First of all, Dr. Anand, who is the graduate from Institute of Science Nagpur, and also a very enthusiastic person because at the age of 65 he has done a PhD as well. After working with a lot of companies associated with Texas Paint, Master Builders, Bahrain, Perma Construction Aids, VIP Polyurea in Germany,
Hello.
HTC Sweden, and CP Polyurethane from Pune. He's held positions right up to vice president and retired in 2014. Currently, he's doing a full-time consultancy for construction chemicals in the name of 𝐒𝐭𝐚 Technology. Sir, we welcome you, Dr. Anand.
Yeah, thank you.
Next, I have Mr. Subhash Patil. He's a chemical engineer with about 40 plus years of experience in the chemical industry. He's a graduate from IIT BHU from Banaras. He has the experience mainly in ammonia, methanol, and hydrogen chemicals. Also, he has worked a lot in the overseas market as well, ranging from Vietnam, Saudi Arabia, Oman, and Azerbaijan. We welcome you, Mr. Subhash.
Thank you.
So now I would like to call upon Dr. Anand to present his views on the construction chemicals and what an entrepreneur should look out for if he wants to set up an industry in the construction chemical sector. Over to you, Dr. Anand.
Good afternoon to all the attendees. And as Guru Prasad has given introduction to all my details, I just start a small presentation on the construction chemical, which is an ever-growing industry. See, as three essentials of life: roti, kapda, and makan. And for the item makan, the primary requirement is construction. And for quality enhancement and improvement of appearance, we need the specialty construction chemicals. That's how the requirement of construction chemicals has grown over years, since say 1985 onwards till today. It has grown from a small beginning of about 10 to 15 crores to today it is about 25,000 crores, and going upwards to 50 crores by 2040 or 50. These construction chemicals are basically additives used with concrete, cement, and other construction material to provide durability, workability, and various structural improvements, waterproofing. Nature of the and the usage depends on the nature of the size of the project. Construction chemicals are used to obtain certain desired characteristics in concrete, such as high workability, high compressive strength, high performance, and durability parameters to meet the requirement of complexity of modern structures. Hardeners are used with the structure to seal them against moisture and making them dust-proof by bonding the crystalline structure of the cement. Admixtures can modify properties of such as workability, water reduction, heat of hydration, dispersion, and air entrainment, accelerating and retarding, etc. Impermeability and durability factors, and commonly admixtures are used are hydrocarbonic acid, then lignosulfonate based, then polyethylene carboxylate based. Construction chemicals provide structures with enhanced bond strength and moisture retention, increased crack resistance of mortar, increased yield with some quantity of construction material, decreased drying time of mortar, and improves appearance. And it is, in fact, there are various sectors in construction chemicals. The different type of products. In the next few slides, you will be able to see that, which I will explain one by one. Next slide, please. Okay, one more thing I want to explain is, on the basis of types of product, the global market is classified in, you can see the classification of construction chemicals are concrete admixtures, waterproofing material, flooring, industrial flooring, then tile adhesives in the tiling sector, then repair and restoration mortars, and then other items like sealants, grouts, and you have performance chemicals, you have other additives which are very important during the construction of building and structures. Next slide, please. And also the construction chemicals globally are segmented into residential, commercial, and industrial. Next slide. Now I am going to give a brief of the types of construction chemicals. The primary thing being admixtures, which are used during the preparation of the concrete in RMCs. There are two types of admixtures, one like chemical admixtures and mineral admixtures. Please excuse me because I don't have teeth so the voice may be slightly aberred.
No worries, sir. We are able to hear you. Maybe when
Okay.
you are explaining each of these, construction chemicals, you can also give a kind of understanding on how much investment
I
will
have
be required.
prepared those slides separately for each item. Here
Right.
in this slide, you get the broad explanation of different items.
Correct.
Okay, these chemical admixtures include plasticizers, accelerators, and set retarders, which are used for water reduction, decreasing hardening, time of concrete or cement. Mineral admixtures consist of fly ash, silica fume, blast furnace slag, and rice husk ash that are used to enhance the property of the cement. Now, the next comes waterproofing. Waterproofing is cement-based, acrylic-based, or polyurethane coatings, which, when applied to permeable masonry or concrete surface, forms a durable finish which is water-resistant. Then comes the densifiers. These are used on the concrete after it has been cured to make it almost impermeable to moisture and hardens the surface. It makes it dust proof and increase the strength of the concrete. Then construction is also used for repairing chemicals, for repairing and restoration of structures, for spalled structures, and improving this performance of mortars are suitable for structural and non-structural repairs. Now, then next comes tiling segment. Tiling segment, you have the tile adhesives. You have got waterproof tile adhesives. You have got waterproof mortar. Then there are tile adhesives which you can fix tiles on the existing tile itself. So the addition of these adhesives are so good that you can straight away, without removing the existing tiles, you can fix tiles on top of it. And it has taken almost since 80 in the earlier stages, people were not accepting tile adhesives. They were used to the conventional system of dipping the tiles in the soaking the tiles in water and then applying cement mortar and fixing it. But presently, people have then slowly shifted to these tile adhesives, and everybody is using tile adhesives instead of plain cement mortars. Then comes the industrial flooring. In industrial flooring, you have different types of system like epoxies, polyurethanes, polyurea, then and of late polished concrete surfaces, where their details will be coming in the oncoming slides. Then we have got sealants. Sealants are also very important because structural glazing has become very popular, and any gaps like expansion joints and the construction joints, everything has to be sealed with proper material. Otherwise, the moisture will penetrate through it. So different types of sealants like acrylic, polysulfide, and form the integral part of modern day construction. Next slide, please. Now, these are the pictures of chemical admixtures. Next slide. Yeah. Admixtures for concrete mortar and paste are inorganic or organic material added to normal components of concrete mix, not normally exceeding 1 to 5% by mass of cement. Admixtures interact with hydrating cement by physical, chemical, or physiochemical actions. They modify one or more properties of concrete, mortar, or paste in fresh or hardened state. Next. Admixtures are usually very complex chemical compounds, excepting a few. They're unlikely to be pure compound, but associated with some minor chemical compound additives, or they may be mixed formulation. Thus, admixtures are those ingredients in concrete other than Portland cement, sand, aggregates, and water that are added to the mixture immediately before or during the mixing of the concrete in the RMCs, ready mix concrete plants. Next. The classification of admixtures. There are different types of admixtures like air entraining admixtures to make lightweight concrete, water reducing admixtures to give high strength. Hello, am I audible?
Good, please go ahead.
Yeah. Plasticizers, super plasticizers, accelerated admixtures, and retarding admixtures. Next. Hydration control admixture, waterproofing admixture, where the crystalline admix is used to make the entire concrete structure waterproof, corrosion inhibitors, alkali silica reactive inhibitors, then coloring admixtures, the miscellaneous admixtures such as such as for improving the workability, bond strength, high strength damp proofing, permeability reducing, grouting, gas forming, and pumping admixtures. These are all the different types of admixtures which are used as per the requirement of the site conditions. Next. For our country, the most common admixtures are plasticizers and super plasticizers. These are also known as water reducers and high range water reducers respectively. Retarders are likely to be needed for specially hot weather conditions in ready mix concrete where the distance has to be covered, or special continuous pours. Other type of admixtures are accelerators, where you want the concrete to set at an early stage. Then air entraining agents, as I told, are used to produce lightweight concrete blocks. Then there are pumping aids to pump the concrete in the multi-story buildings at a high level. With these pumping aids, actually it helps in the plasticity and the fluidity so that it is easily pumped to the higher levels. Then shotcrete and gunite aids. Then corrosion inhibitors these are the other types of admixtures. Next. Advantages of admixtures are improvement in strength of concrete. Then while casting the concrete, there is an improvement in workability. Then weather conditions, like hot weather, if you add admixture, you get better time for finishing the concrete and getting a better easy workability. Then the accelerated curing time. Then you have admixtures for waterproofing also. As I told, the crystalline admix is for waterproofing. Then these admixtures.
Can you also tell us on how much would it cost to set up a plant if somebody is looking to set up an admixtures?
That setting of a plant is coming at the end. How much it will cost?
Okay.
On the next slides, there are almost at the end of the presentation. You also get.
Right. Okay.
Now this is a broad picture of how next is waterproofing chemicals. Now waterproofing chemicals, where all it can be used in a housing structure. So this you can see that it can be used in terrace, for the terrace floor, for the tanks, water tanks, then the sunken slabs, all these areas in the terrace. Then for the walls, you can use for interior and exterior wall waterproofing. Then you can use for underground sumps. Then all the underground structures, you can use the crystalline admixture, waterproofing admixtures to make it totally waterproof. Then you can also damp proof the walls. The crystalline admixture you can use it from the negative part also. from the negative side also. Next slide, please. Next slide. Yes. No. The waterproofing system covers every need of building and construction, as I told, industry to protect from water ingress or loss of water through structures. The complete building structure from basement to roof are protected from rising dampness, moisture, seepage, leakage from basement to roof. The technology ranges to acrylic, SBR latex, crystalline, epoxy, water repellent polysiloxanes, polyurethanes, bituminous based formulations. These are the different types of waterproofing material. The coating fills and seals the concrete pores, micro cracks, capillary cracks in joints, walls, floors, through which water seepage can occur. And an integral part of waterproofing compound without breaking and existing brick coba and concretes. That this is about the roof terrace waterproofing. Next. Main features of waterproofing are excellent resistant to hydrostatic pressure. These are the conditions in the basement level. Resistant to water and chemical ingress. In the seashore area, the water is very corrosive, and if it is properly waterproof, it is resistant to these chemical ingress. Then there is protection from moisture permeability in high water table area. The water table is high, the moisture can permeate from the floor, and if it is properly waterproof, this moisture will not permeate. Protection from corrosion. If it is the terrace area, etc., wherever the rebars are used, reinforcement bars are used, if there is no proper waterproofing, moisture will penetrate and the bars get corroded. And in due course of time, they will form the rust, they will expand and they will spall. Spalling will occur and it will start degrading. So waterproofing is a very important aspect. Can be applied on old and new structures. Can be applied from negative side also. As I told, the crystalline waterproofing system can be applied from the negative side. Normally, the waterproofing is done from the outside. But suppose your structure is complete and then you have a problem, this crystalline material can be applied from the negative side inside, and then that material will go inside the structure and waterproof the capillaries, seal the capillaries, and the structure becomes waterproof. Next.
Sir, in this case, one more doubt that people also have is there are already players like Dr. Fix-It, or it could be Asian
Yeah, I'm
Paints.
coming to that. I'm coming to the players segment.
Right. So how does the new entrepreneur compete with such players?
The industry is very big, and like I told you, from 8 crores, it is going to 50,000 crores. The market is very big. Everybody has got their share, and the more the merrier. So the segment I'm telling, there are big players, medium-sized players, and small players. Everybody doing their business. Now, applications of wherever waterproofing can be applied. The tunnel construction, retaining walls, foundation walls, parking areas, terrace gardens, cooling towers, balconies, terrace basements, underground sumps, reservoirs, ponds, kitchen and wet areas, podium, roofs, exterior and interior walls. These are the areas, that means the complete areas where waterproofing has to be done. It's a mandatory thing, otherwise the structures get dilapidated very soon. Yeah, next slide. Next. Next is the segment is the industrial flooring. Industrial flooring, there are, as I told you in the beginning itself, there are like epoxy is there, polyurethane is there, polyurea is there, then you have got polished concrete flooring. So this epoxy, polyurea, and next slide. These are the pictures. Next slide. Yeah. Industrial flooring plays an important role in productivity, safety, and housekeeping. which has gradually with time changed from conventional cement-based flooring, tiles, etc., to monolithic floor toppings and coatings. We have today a very varied option and range such as flooring material which are usage specific, like polyurethane and PU concrete flooring, then epoxy flooring, polyurea flooring, polished concrete flooring. I explain each of them in the next slides. Next. Now, polyurethane is a very tough and durable flooring material, giving a longer life. The unique chemistry of the material gives the combination of high flexural strength and durability and chemical resistance. Here, the polyurethane chemical base and hardeners of the system are mixed together at site and laid to the desired thickness, maybe 1 mm, 2 mm, up to 4 mm desired thickness, and finish to the fine finish with the pictures depicts. Next. Now, epoxy floorings. Since it has been very popular since the 1990s. These are engineered chemical adhesives that bestows the industrial floors with the durability, scratch resistance, chemical resistance, besides strength and bonding to the basic substrate, concrete substrate. So these are the qualities of the epoxy. These are also base and hardeners are mixed at site and laid to the desired thickness by specialized applicators. Next. Next slide. The advantages of epoxy flooring is it protects the concrete floor, gives chemical resistance, it is washable with water and also steam, provides clean and pleasing atmosphere. You can have the color of your choice. It is very hard and scratch resistant. Here the polyurethane, the advantage of polyurethane flooring is that it is UV resistant. Epoxy can be used only to the internal floors. The external area, polyurethane has to be used because the epoxies, they chalk when exposed to the UV rays. So that is the limitation of the epoxy flooring. Next. This polished concrete floors. These have been quite popular since the 2008 or so, and this is done like the hard floor, like M25 grade concrete floors. These are densified with concrete densifiers and then polished with planetary grinding machines. And you have got fixed to those diamond tools are fixed in the grinding machines, and then their polishing is done in 7 steps. There you get a very tiny surface, easy to maintain and water resistant also. And present these days, like I can tell you an example of Daimler, the factory, Daimler trucks. About 1.5 lakh square meters of floor. Everything was made as a polished concrete floor, so that it is there is no topping on it. Breakage doesn't occur.
Where is this, sir?
This is in Oragadam, Chennai.
Oragadam.
It's a very big factory, and like that, many European. This system became very popular in Europe and States, America, and also Australia. And India, it is catching up slowly, and now it is very these days it is getting specified in most of the projects. Some areas are definitely with polished concrete surface. Next is the tiling range. As I told you that these days everybody uses tile adhesive, where the bed height is very thin. It used to be almost 12 to 25 mm mortar used to be required when the previous original tiling used to be done. Then at this, once the tile adhesive came into being, the thickness is the mortar is very thin, and also the adhesion is very high, and it is uniform, and fixing is easy, and also it's not very, it is very clean. Washing and all is very clean, and fixing once, and it can be very quickly fixed. And even the old tiles, you can fix new latest tiles with these tile adhesives on top of the old tiles without breaking. Next slide. Next. These are actually primarily, these are premixed blend of exceptional, well-chosen ordinary Portland cement, well-graded fine sand and additives to improve the basic properties for laying tiles and giving it more strength and flexibility. So that is the basic property of the component. Next. Advantages of these adhesives are improved durability, easy installation, time and cost efficiency, versatility in application, enhanced moisture resistance, flexibility and crack resistance, environment friendly, and easy cleanup. And this can be used in these waterproof tile adhesives can be used in swimming pools for fixing the swimming pool tiles. So it's a very wide application is there in 5-star hotels. The swimming pools are there, so there's a very good demand for that. Small tiles, they are applied with these tile adhesives. Next comes the sealant segment, construction sealants. So any construction, any flooring, big flooring, they do have construction joints and expansion joints. So for us, flooring is concerned. Then you have got when structural glazing is done, the glass panels are sealed with silicone sealants. When they have two glass panels, and in between vacuum is there, and they seal the sides with silicone sealants, and they fix it with silicone sealants. These expansion joints and construction joints, there are different types of seals in the market, and wide joint sealants are there for very big joints. These help in keeping the floor, because there is a thermal movement is there. So the sealant, that is why the joints are provided, and the sealants help to keep the things in level, and also the aesthetics of the floor. Next slide. They don't allow the passage of fluids through the openings, and making it waterproof. The sealants, there are different types of sealants like acrylic latex or polyurethane based, and also serve the purpose of blocking dust, sound, and heat transmission. Sealants may be weak or strong, flexible or rigid, permanent or temporary, as the requirement may be. Sealants are not adhesives, but they have the quality of adhesives and are called adhesive sealants or structural sealants. Next. These they don't have despite not having great strength, they seal the top structure to the substrate, and are particularly effective in waterproofing process by keeping moisture out. The compounds in which they are used, they can provide thermal and acoustical insulation, and may serve as fire barriers. They may have electrical properties, as well as sealants can also be used for simple smoothing or filling. They are often called upon to perform several of these functions at once. This caulking sealant has three basic functions. It fills the gaps between two or more substrates. It forms a barrier through the physical properties of the sealant itself, and by adhesion to the substrate, and it maintains sealing properties for expected lifetime, service conditions, and environment. The sealant performs these functions by way of correct formulation to achieve specific application and performance properties. Other than adhesives, however, there are few functional alternatives to the sealing process, where it is used as a fire resistant sealants are there, which these days are mandatory when the electrical thing and as a precaution for fire resistant sealants are used. Next.
Sir, there is a question that since a lot of these paint industries are getting into waterproofing, is there a demand that will be there for the purely waterproofing chemicals industry?
All these see, like I will be telling in the next slide, there are more than 400 plus formulations and different type of material.
Okay.
So all these things are used. That is why when you have a construction chemical industry, you need a range of construction chemicals, because you don't know what type of, when you go for marketing point of view, you don't know what orders you will get. If you say you don't have this, then the customer is going to other person who is having everything. Everybody wants to buy from the same source, and so that you need a range of construction chemicals. That is why it is very big, and anybody can come into it. There are people who are only doing one product and selling throughout the world, like the crystalline waterproofing chemical. There are companies manufacturing and experts. There are 2-3 companies all over the world who are just selling in 80 to 100 countries. The companies like 𝐒𝐿𝐼, yes, silicone sealants, acrylic sealants, siliconized acrylic, then polysulfide sealants, in which you have gun grade and pouring grade, then polyurethane sealants, both gun grade and pouring grade, then epoxidized polyurethane sealants, where also you have pouring grade and gun grade. Next. Now the other type of construction chemicals are grouts. These are machinery grouts. Fixing any machinery in an industry, you need grouts. There are cable grouts. Like that, there are almost 8 to 10 different types of grouts for different applications. There are then the repair materials. These repair materials are required for the old structures, for repair and renovation of these cementitious structures. These are all cementitious products. And you do have also epoxy repairing material. These are used for grouting and sealing. These products are non-shrink in nature. Any grout will be non-shrink in nature, because the basic problem with cement is it shrinks. There is a small shrinkage problem. That is why it develops cracks over a period of time. And if especially in grouting and all, it is not advisable to use only the ordinary cement. So it is having those non-shrink additives in that. So these grout materials, we'll see that there is a small, very slight amount of expansion, and it keeps the machines in a very proper position. Next slide, please. Construction industry chemical, as I have told you, it has grown from few crores to 25,000 crores, and to the present day, and towards it is 40,000 crores by 2030. The global market requirement is projected $50 billion by the year 2030. And there is also a lot of scope of these products being exported to third world countries. It is happening. The industry covered by 3 types of manufacturers. The multinationals like BASF, Penatron, Mapei, Schaumburg, 𝐿𝐼, then the RPM Group, Huntsman. And there are companies who manufacture only one product, like Huntsman manufactures epoxies. Then you have your companies like Laticrete manufacturing only the tiling range. Whereas companies like BASF and MAPE and all, they make each and every chemical and the raw material of the complete range. The Indian multinationals like Pidilite, Asian Paints, your Pidilite, the Dr. Fixit, CP Polyurethane, Fairmate, and then the Sunanda Chemicals. They are all the Indian big companies, big players. Then you have got medium and small manufacturers like Ultracon, Infrachem, Gurgaon, then Compact Mix Coimbatore, Monarch Industrial Products, Teni, Build Care in Mumbai, Buildcore, and then Perma Construction Aids, Vapi, Petrocoats Chennai, and many others, many others. If you go to construction chemical associations, you can get you can see how many members are there. You become a member, you can get those membership lists. There are it's a very big list. But the medium and small also covers about 35 to 40% of the Indian market. And they are what they do in the local areas. Wherever they are, and they sell in the local areas, popular in locally. They don't go like companies in Tamil Nadu may not go to the northern side because of transport. So that is how the industries work. Next. Now this is a SolutionBuggy can arrange for suitable consultant investor meeting to provide you with A to Z details of setting up a construction chemical manufacturing unit. A brief for the investors interested in setting up the units. The selection of range of products. It can be one single category of product or complete range or a few categories. This is possible. And the manufacturers who intend to manufacture, they can also get products toll manufactured in the initial stage and then slowly enter into the manufacturing once their market is established. So that is another way of getting into the industry. Then budget can start from rupees 30 lakhs for one category to rupees 3 crores for the complete range. This includes plant and machinery also. It can be a complete automatic plant, a lab, and initial investment of raw material. Land and building shall be extra cost, that is there, that has to be provided. The
So when
consultancy
you say
charges are
one
included.
category, it could be
Yes,
a category like sealant or admixture or like that, right?
that will completely all the range of products will come. That is in 3 crores.
When you look at 30 lakhs for one category.
Category.
Right.
Now, because the machinery is going to be same for all the, so that's one set of machinery you have.
Right.
Consultancy charges are included in the above budgetary figures. And one small caution is that since the range, as I told you, the range is very big. Each category will have a minimum of 10 to 15 products and the derivatives thereof. The total works out to about more than 400 product formulations. So one has to increase the range cautiously as the inventory shoots up, because orders vary as per requirement, which varies very drastically. Yeah.
So in that case, how much area would be required to set up such a unit?
For an automatic plant, you need initially you will require about 20,000 square feet, 2,000 square meters.
Right.
For a small plant, maybe 500 square meters.
Right.
So there's an example like crystalline admixture. It is getting specified in all the government projects.
Okay.
Like these highways and bridges and all those things. And order values are nothing less than 1,000 crores. That is the present day condition. Only for one product, waterproofing with crystalline admixture.
Right.
Yeah, next slide. This is I thank you everybody for listening patiently, this old man. And any help from my side, please contact SolutionBuggy. Anybody, any one of the SolutionBuggy executives, and they will guide you for the how to go about it. We have successfully completed first few projects also.
Sure. So the key takeaway is basically that construction chemicals by and large has a category of products that one can look into, and based on the investment that one can put in, he can either go for all the categories or select a few categories. But as Dr. Anand also mentioned, the industry can have drastic change in requirements. So to ward off your liabilities, you can probably look at least 2 to 3 categories, so that even if one sector, one category is not performing well, you can break even in the other categories. So having said that, the investment range can be anywhere between 30 lakhs to 3 crores and even more. And your potential consumers can be any of these large B2B players who typically have, who again are in the same category. Like some of them are very focused on a few categories only, whereas some of them have all the bouquet of 400 plus chemicals with them. So these people can be a good target market for you initially, until you can build your own brand and things like that. And also a few, private labeling opportunities can be there, but again, it is not as easy as in the F&B and FMCG segments. Thank you, Dr. Anand, for a wonderful session.
Thanks for listening.
Yeah, and any questions? Maybe after Mr. Subhash's session, we will reroute it to you. Okay. So now I have Mr. Subhash Patil. Like I mentioned, he'll be walking us through methanol and green hydrogen and other chemicals that he feels have a good potential in both the transportation sector and also in the steel and cement sector. So over to you, Mr. Subhash. Mr. Subhash, you are on mute, I think.
Hear me?
Mr. Subhash, you will have to unmute yourself. Yeah. Now we can hear you.
I can start, no?
Yes, please.
Okay. So, yes. Today we'll be talking about the renewable fuels. That is green ammonia, green hydrogen, and green methanol. So this is a new, because of the this CO2 pollution. This is now upcoming business opportunities coming into this field. So because everywhere in all America, Europe, and these business opportunities are generated in the green hydrogen, green ammonia, and green methanol. So why we call it green methanol, green ammonia, and green hydrogen is that, so in this production, there is no generation of CO2. So that's why we call it green. And the electricity we are using, the electricity is used, the generation by wind, solar turbines. So that electricity does not have a role of CO2. Like, electricity we are generating normally is by this thermal, by burning natural gas, that is gas turbines. Then thermal power plant, that is using coal. So that electricity is not a green electricity because it has a generation of vast amount of CO2, and this CO2 is thrown into environment. So that is not green. So we call it this hydrogen generation, ammonia generation, and methanol generation, we call it green because the electricity used in this generation is from the solar mainly, solar and wind turbines. So that is a green electricity. So we call it green ammonia, green methanol, and green hydrogen. So now this business opportunity is coming because these are going to be the fuel of the futures. Green methanol, green ammonia, and green hydrogen are the fuel of the futures because slowly gasoline and natural gas, which are used as fuels now, they will be replaced by the hydrogen, methanol, and ammonia in the next 20 to 30 years. That is the plan to control the CO2 emissions and to reduce this CO2 emissions to the minimum possible. Now we'll go ahead with the generation of green methanol, how we do it. And in the conventional methanol, what we do in the conventional now, at present, how the methanol is produced, so that this slide explains. So we have a steam and natural gas which is coming from Bombay High, that natural gas, and steam. So we are sending to the reformer, where this reformer is simply a catalytic tubes type, where some catalyst is filled in the tubes. And there we are passing this natural gas and steam through the catalyst. And there we are generating this CO2, and hydrogen. That is called steam reforming reaction. Steam reforming of methane. Steam reforming of methane. And this generates CO2 and hydrogen. And this generates also flue gas. Reformer outlet is a flue gas. So this flue gas consists of carbon dioxide and small quantity of few ppm of carbon monoxide. So this is a conventional methanol where we do not have the CO2. We have a lot of CO2 generation here. And this methanol goes to converter. This is methanol converter reaction here. And then this goes to distillation. And from distillation, we are getting methanol and water. So we'll go to, this is the methanol converter photograph. You can see it is a chemical reactor where the CO and hydrogen react to form CH3OH. CO hydrogen and CO2 hydrogen both react to form CH3OH, which is the methanol. So we'll go to next slide. Yeah. Now earlier, this is one of the main methanol production from natural gas and methanol production from coal. In China, China do not have much natural gas. They have vast resources of coal, China. And I have visited China also because I went to one of the methanol plant commissioning there because I was working with Albert Topsoe. They have a methanol technology licensors there. So I was sent from the Albert Topsoe side to the China, and they do what they do. They gasify the coal. Coal is mixed, made in the form of powdered, and then it is gasified in the gasifier. And that generates CO2, and hydrogen from the coal. And also it is mixed with steam. So hydrogen is coming from steam and CO2 coming from the coal. And further CO is converted to CO2, that also generates some hydrogen. So this is the picture. You can see the flow diagram of the coal gasification, methanol from coal. So here there is you can see oxygen, steam, and coal. Three are fed to the reactor. This is oxygen, this is steam, this is coal. So this is fed to reactor. and from the bottom is coming ash, and slag, which is coming from coal. And then this goes to the shift converter where CO is converted to CO2, and that simultaneously generates hydrogen. And then this goes to acid gas removal, where acid gas means hydrogen sulfide, because coal has some sulfur. So in the reaction, in the gasifier, the sulfur is converted here. There are some organic sulfur compounds in the coal. So these compounds are converted in the acid gas here to source shift converter. They are converted to the H2S and CO2 in the shift converter. And acid gas removal, they are removed. So hydrogen sulfide and CO2 are removed. And then this goes to methanol synthesis. This is one way to produce the methanol from coal. Earlier we have seen, first slide we have seen methanol from natural gas. Okay, next slide. So methanol is the conventional fuel from the earlier stage, which is produced from natural gas and coal. So this is just methanol production bridge to sustainability, means how we'll sustain on the methanol this. There are various, expansion of energy markets for methanol builds demand for sustainability and source. So these are the different fossil and natural gas, and this all are combination. Next slide. Now, several renewable production pathways exist. Now we have seen the conventional pathways. This is the first one. Conventional. CH4, that is methane, or you can see natural gas. Then reformer generates CO, CO2 hydrogen. It goes to reactor, and in the reactor, CO, CO2 and hydrogen react to form methanol, raw methanol. Then raw methanol is purified in the distillation, and CH3OH is the pure methanol. So this is the conventional route. Now we have a new route now that we will go ahead. So there we call it CO2 recovery and utilization. There are different options. We'll see in the next slides. And then liquid electricity means electricity we store in the form of methanol, or electricity we store in the form of ammonia, or electricity we store in the form of hydrogen. How we can store? Because this solar electricity we cannot store because it is available in the daytime. We cannot store it. So how to store this electricity? We produce methanol, we produce green ammonia, we produce green hydrogen using this electricity, and that is converted to liquid electricity and stored. So this is how we utilize this electricity. Otherwise, there is no storage for that. It is just wasted, solar electricity is just wasted. So we have to use it this way. And CO2 recovery and utilization. Also CO2 generated in the system like, conventional ammonia plant, and a lot of CO2 is generated. So that CO2 is now recovered and stored. Mainly now CO2 is stored where? In the oil fields. They dig the deep, they call it deep disposal of CO2. The CO2 is just under pressure, it is sent to the oil reservoirs. And this CO2 builds the pressure on the oil reservoirs, and this pressure is utilized to for the recovery of oil, because oil can be recovered more in the high pressure. So this is the use of the CO2 recovery. So we'll see the different options in the next slide. Okay, next slide. This is basically same biomethane. biomethane means nothing but methane, natural gas generated by biological waste. Biological waste is nothing but in the sewage treatment plant and agricultural waste, manures, they are generating gas. So that is biomethane. Next slide. This is the photograph of the reformer we use for the production of synthesis gas. This is just an idea to give how it look like. Next slide. Now CO2 recovery and utilization. Now when we fire reformer in the conventional, there is a lot of CO2 generated. So this CO2 has to be recovered and stored. So those plants, those plants are called blue plants, like a blue ammonia. Also, along with the green ammonia, there is a blue ammonia. So blue ammonia means ammonia generated by the conventional method from the natural gas. That is blue ammonia. But the CO2 generated in the process is recovered and stored and utilized for some other purpose, like the pressurizing the oil reservoirs, like that. Or you can use this CO2 for the production of methanol. That can be done. So CO2 recovery and utilization. This is how we can use the CO2 for generation of methanol, or CO2 can be used for the oil reservoirs. CO2 is pumped underground in the oil reservoirs to build the pressure in the reservoir and to get higher oil production. Next slide. Okay, so these are the Qatar fuel additives utilization record CO2. So this is the diagrams for the CO2 recovery plant, different. CO2 is recovered from different sources. Because CO2, which is in the, along with the hydrogen, there is a CO2. So we have to recover this CO2 from the hydrogen to use this hydrogen for the fuel purpose. So there are different methods for CO2 removal, means acid-amine method. Then the BASF Germany has a activated MDA process for the utilization of excess removal of CO2. Yeah. The CO2 extraction from the flue gas, then injection in the methanol plant. So CO2 recovered can be used for the methanol production. So that is a great advantage of methanol production, green methanol. That CO2 can be used. That is a carbon recycling, we call it. In other process, you cannot use CO2. You have to just store it, compress, store, and dump under oil reservoirs. But in the case of methanol, green methanol, this CO2 can be used. So it is a great advantage in that way compared to ammonia.
Typically, when you look at these plants, you have given one or two options here. So what is feasible to be set up? Are both of these feasible?
Pardon?
No, if somebody wants to set up this plant in India, or
Yes.
an entrepreneur wants to go for it, so
Yeah.
both these options are
At present, one option is already going on, the conventional option. There are methanol plants at presently in GSFC Baroda, Rashtriya Chemical Fertilizers, and other areas there are methanol plants. And that methanol plants are now running on the natural gas.
Okay.
Yeah, this is already going on presently. But now new evolution is coming up. or the green methanol that will be generated by hydrogen from electrolysis and CO2 available, stored CO2 available.
Right.
Yeah.
And
So
what
will
are
be,
the typical costs of setting up these plants?
that cost at presently is a little high because cost of electrolysis is presently high.
Yeah, electrolyzers are very costly, no?
Yeah, that is challenging now. But slowly, the research is going on and the cost is coming down. So as per the normal, they want to bring down the cost of this electrolysis to $1.
Right.
$1 per kg of hydrogen generated. At
Now,
present, it is around
right?
at present around $5 to $7 per kg of hydrogen. Hello.
Right. Right.
Huh. At present, $5 to $7 per kg of hydrogen. Now,
Correct.
this plan is to bring down to $1 per kg of hydrogen generation
Right.
cost. So this is challenge, and for that, new research is going on in the development of cheap electrolyzers. And then it will be feasible to set up small units also for generation of green methanol, green hydrogen.
So suppose the hydrogen is not split from water with this method, and we are using the conventional energy, then it becomes gray hydrogen, is it?
Yes. If at present hydrogen is produced as a gray hydrogen.
Okay.
So gray hydrogen means we are generating hydrogen from natural gas in the reformer, and the generated CO2 that is vented into atmosphere.
Mm-hmm. Okay.
So that is called with gray. And blue means we are not venting CO2 into atmosphere, but we are recovering that CO2 and stored separately, compressed and stored separately. So that
So
is
the
blue.
only reason why the green methanol will have a higher rate is because it is produced by using green hydrogen.
Using
No, I'm asking the only reason why green methanol will have a higher rate is because it is produced using green hydrogen, is it?
exactly. Because green hydrogen is expensive. And that is generated by electrolysis of water.
Right.
So the cost of at present is higher.
But what we have also seen from the government policies is methanol is being blended into diesel, like there is MD15 and all.
Yes, it will be used as a fuel.
Correct. So
Yes.
in that case, an entrepreneur wants to get into methanol manufacturing, then he can still go for it, right?
Yes, you can go ahead with the methanol production that can be used as a fuel additive.
Correct.
That can be mixed with gasoline,
Right.
10 to 20% methanol, rest gasoline.
Right.
Like that. So it has a vast scope now. So green methanol.
Correct. Because most of the transportation trucks and buses are using the diesel fuel. So, and also some of the state transport corporations are experimenting with MD15 as one of the fuels. So, where methanol can be used, right?
Yeah, correct. So that is one of the. Also, methanol has got many other applications. Methanol can be used for production of many other chemicals. Methylamines.
Right.
Methanol and ammonia can form methylamines, which are used in many pharmaceutical industries in small quantities. Methanol, formaldehyde, we can use for production of formaldehyde. So there are a number of chemicals we can be produced from methanol. So it has a vast scope. We'll go to next slide. This is the typical slide for the CO2 recovery from the flue gas. So flue gas, chimney, conventional chimney of the stack. from any factory, the chimney has CO2, mainly a lot of CO2, and little CO and some other gases. So this CO2 can be recovered in the absorber. This is absorber. So here you can see this flue gas, which has a mainly CO2, is sent to the bottom of the absorber here, and then it passes, and from the top of the absorber, we are seeing some solution, and there are two stages at the top and the middle. So this solution at present is methyl diethanolamine, that is used, MDA called, widely used as a CO2 absorbent, because CO2 is absorbed in the MDA, and simply for removal of CO2, we have to just dissolve the stripper. This is stripper. So what CO2 we are getting, this solution is getting absorbed. So this absorbed solution along with the CO2 in that is sent to the stripper, where with the help of steam, it is heated, and this from higher pressure it is flashed to lower pressure, and CO2 is generated. So this CO2 purity, like here you can see, 99.9% CO2 is removed from the flue gas. So this is the gas we are venting in the atmosphere is free of CO2. So this is the advantage of this process, CO2 removal process. And then this captured CO2 we can compress and store, or utilize some other purpose, like a production of methanol. This is typical process for the CO2 removal from the flue gas. This is widely used now everywhere, because government do not want the CO2 in the atmosphere. So many people are setting up these units in their factories to remove this. Okay, next slide. This is again, we are going to the basic options. So this already, some part we have discussed already, like a Westwood, black. This is sent to West, organic waste. Organic waste is sent to gasifier, and this this is called biomethanol, because it is coming from organic waste, the manures, the sewage treatment plants, methane from sewage treatment plant, that all is coming. Then it is crude biomethanol is made, distillation is made, and there we can get also dimethyl ether and ethanol in the distillation column. So this is a small basic things, how we are generating methanol. This already shown in earlier slide also. This is just a revision. Next slide. This is the photograph of the world's first commercial biofuels and chemical facility. So this is just to show. This is the use capacity, 38 million liters per year. This one. This is biomethanol, that is called. Okay, next slide. This is the same storage. This is showing the storage picture and other the synthesis units, gasification section. Okay, next slide. Okay, this is the same again. General photograph. Next slide. So this is a liquid electricity. This is what now today's mission. Convert the solar and wind electricity into liquid electricity, which we can store. This is option 4. And this is today's option now. This business opportunities coming up now, evolving into this sector. So this is, like you can see, the solar, electricity from the wind turbine, and this goes to electrolyzers. Yeah. And then CO2 captured, as we have discussed before, CO2 captured by CO2 recovery system, like flue gas, CO2 from flue gas, recovered. This then electrolyzer, hydrogen coming from electrolyzer, and CO2 coming from CO2 capture. Both are going to reactor, then distillation, then e-methanol. That we call it e-methanol, green methanol also, e-methanol. So this is the overall picture. So this is what we convert electricity from solar and wind into liquid electricity. So daytime we are using this. The production will be highest in the daytime and the lowest in the night time. So these plants, which are like green ammonia and green methanol, plants are designed from 10% to 100% capacity. So during night time, they will be running at a very low capacity. They have to use maybe grid power to run it, just power from grid. And daytime, they will be using power from solar, like that. Okay. Next slide. This is a renewable methanol plant photograph. This is Carbon Recycling International. So they are doing that. So methanol is nothing but we are recycling CO2. This is the great advantage of methanol. We can use CO2. Next slide. Now, this option 4 continuing. Pathways to storing renewable electricity. So electricity storage, this is also a challenge. Earlier it was not happening, but now we are using the option convert electricity into liquid storage. Converting intermediate renewable power, because this power is not available during night time, only daytime. So we are using this power to store in the form of liquid electricity as an alternative option to e-mobility while reducing the CO2. Amount of energy stored in 1 cubic meter of methanol equal the storage capacity of 2 battery electric BMWs. That much is the 1 liter of methanol has so much power to store, of electricity power to store. Yeah. Okay, next slide. Yeah, next slide. Now new markets are developing for this. Current methanol demand and potential market demand. So this potential demand will be rising too much, you can see. Methanol to olefins, there is so much. Methanol to gasoline. At present, there is a Hurler Topsoe company where I was working. They have designed to convert methanol to gasoline also. So we can produce methanol and then convert to gasoline. So there is a separate technology available. And this will be used as like a gasoline, petrol. Methanol will be fully converted to gasoline and used as a petrol. So there is a tremendous demand for this. Fuel cells. Fuel cells means they are used in the cars. So this is also a new development, fuel cells. And gasoline, biodiesel, and DME, these are the normal fuels, and the methanol is a green fuel. And these are the current demands, and these are the potential demands. You can see the use demand for the future. So there is a lot of growth potential. Next slide. So these are the methanol in gas-powered turbines. So instead of natural gas, you can use also methanol in the turbines. So it will replace. So you can see Israel Electric Corporation DOR performed trial conversion at Kasala power plant located in Valley. So their trials are going on to use methanol as a fuel in the turbines. And slowly, it's instead of diesel or natural gas, methanol will be replaced. Commercial operation of 100% methanol fueled these turbines are now developing. Next slide. Now you can see low-cost fuel system retrofits to methanol with this initial project cost so much. These are different projects going on. Here now permitted to operate this methanol consumption is 30 tons per hour. So how much methanol will we use? These technologies are developing to use methanol. This technology is adopted in many other places where due to no natural gas supply, they are currently polluting the fuels. So instead of where there is no natural gas supply, so this technology using methanol can be used. Next slide. Other applications like methanol in cooking stove applications. So this is other countries already using that methanol. In Nigeria, polymer distributed fuel already. So these are the different applications. So instead of other kerosene, this one that it will replace, which generates significant CO2, harmful particles, potential hazards. Wood generates a lot of CO2. And kerosene and paraffin, diesel also generates a lot of CO2. So they'll be replaced by methanols. And slowly it will reduce CO2 generation. Next slide. Hello? Methanol powered cook stoves, same. This is another different application of methanol cook stoves. Next slide. Yeah. They are manufacturing methanol from.
So you can also tell us about, the typical, as of today, what are the typical costs of setting up a methanol manufacturing unit?
Yeah. Today's methanol manufacturing units, because now mainly methanol is manufactured using natural gas, that is gray methanol at present. So that cost is almost, you can say, depends upon the capacity of the plant, but it varies from, around, its cost is, you can say from 600 to 1,000 crores for medium scale plant. So that government is actually setting up. But these small plants can come up using the electrolyzers later on. But that cost of electrolyzer exactly not how much it will cost, depending upon the type of electrolyzer we are using. And that mainly the methanol units using the electrolyzers are coming up now in the developing stage. So that cost is yet to be, data is yet to be available for that.
Right. Okay.
And so China is mainly manufacturing gray methanol using coal potentially at present, and they are also on the way to green methanol production, but not much. It is still development stage in China also. Next slide. Now this another fuel cells. Direct methanol fuel cells. So these fuel cells are used mainly, you can see methanol reformed to hydrogen gas before being fed into fuel cells, high efficiency. The fuel cells are used for this transport cars, but they are not at present very popular. They are still in the development stage, these fuel cells. Because nowadays these electric cars have come, electrical vehicles have come. So fuel cell use is now not that popular, because now people think that this electric vehicles are much easier to drive compared to fuel cells, is little bit complex.
Right.
Yeah, so fuel cell development has now slowed down. So when there was no electric vehicle, this development was going on and research was going on in the fuel cells, which has now slowed down, and it is, I think, not much given much importance now because of electric vehicles. This is the next slide. This is same fuel cells. Next. These are the who are the fuel cell producers. They are given names. Orza, United States, Germany, Japan. They are producing fuel cells. But as I said, fuel cells are less popular now. Okay, next slide. That's all. So this is the overall. Now some questions we can discuss. So
Right.
somebody has something to ask.
Right. So I think
Also I would like to, although it is not in this slide, but I would like to elaborate on the green ammonia some shortly. So green ammonia is also like it is from the green hydrogen. So electrolysis hydrogen is given, and then from ammonia we need nitrogen. So that nitrogen is coming from the air liquefaction. Air liquefaction. So liquefaction of air, that will remove the nitrogen and oxygen separately. So oxygen will be used for some other purpose or vented into atmosphere, and the nitrogen will be used along with the hydrogen to produce green ammonia. So one of the world's biggest, I think, around 2,000 metric ton per day, 2,000 metric ton per day of green ammonia is being installed in the Saudi Arabia, NEOM, company NEOM. And using the air product is they are the joint ventures with the Saudi Arabia. They are producing this green ammonia. And also green ammonia is to be used as a fuel in future, like in marine fuel. Mainly it is designed for the marine fuel in the ships. So ammonia will be stored in the tanks on the ships. And this ammonia will be used as a fuel instead of diesel. So this is the present plan. And also ammonia will be, how it will be used? Ammonia will be converted into hydrogen again in the process. And hydrogen is fired as a fuel. So basically the hydrogen will be burned. Even methanol also, it will be converted into hydrogen, and hydrogen will burn when methanol is used as a fuel. So this is the green ammonia, green methanol, and green hydrogen. So this is, yes, any question you said?
So we were looking at like how you said, there is an option for making of both green methane and also green ammonia and also finally green hydrogen. So if typically somebody wants to set up a unit, who are the kind of customers that they can look out for? Who will be the end consumers?
Yes, private parties actually who are at present handling, suppose they are interested to join this, because the government has some incentives given, manufacture of green hydrogen and green methanol and green ammonia. So these, they can use the incentives to reduce the production cost. And mainly the business houses, not small industry, it will not come as a small industry, but medium business houses, they can look into this manufacture of methanol. That is what I think, green methanol.
Right.
Yes.
Dr. Anand, are you there? I'm not sure if Dr. Anand is there. But anyways, see, the biggest concern people have is, since it's a new technology and also, it is being still adopted in most of the developed countries. But
Yes.
countries like India and all, it might take a long time to, adopt the green hydrogen and green ammonia kind of projects. So if somebody is investing the money, can he start small and then later look at bigger expansion? And if he's small, what kind of typical investments he should look at?
Yes, some parties means you can also start from the small units, like suppose you want to manufacture green ammonia. So now one unit coming in the Saudi Arabia, there is 2,000 metric ton per day, green ammonia. But ammonia can be manufactured in small quantity, like up to 300 tons per day. You can lowest capacity is around 300 tons per day ammonia, and methanol also can be around. There are methanol plants presently around 5,000 tons per day of methanol plant, big. But methanol can produce at a lower capacity of around 250 to 300 tons per day also. So the cost will be smaller comparatively. The bigger plant may have like, $500 million or 0.2 to $0.3 billion. So this compared to this will be very low. Like, but still not very low. It will not be lower than, like 500 crores or like that minimum.
Right.
Yeah.
And where does the one go for technology? Like, is it available in India, or should they go for joint ventures with German companies or something like that?
Electrolyzers are being made in India presently, alkaline electrolyzers. So they can be used. Some companies are already manufacturing, in the stage of manufacturing this alkaline-based electrolyzers. So mainly electrolyzer is the main thing for hydrogen, and then, but it is at present available in India, so no issue.
So technology is available.
Yes. Technology available.
Okay. Right now, only government has invested into these plants, right? There are no private players.
At present, government is investing in a big amount, but I think some private party also interested. Recently, I have visited one party in the Hyderabad. They are interested in green ammonia, so they called me for the advice. So I attended one meeting there. They are interested in the 300-ton ammonia plant, green ammonia plant. So they were asking me the electrolyzers type, which to be used, and then any restrictions or any limitations like that. So smaller scale, you can start like 300-ton green ammonia, 250 tons of methanol, and even smaller scale green hydrogen.
Okay. And also, when you say this 300-ton plant, so typically, what is the area required to set it up? Land area?
300-ton plant area, because suppose the electricity you are just getting from outside. The electricity area means like, the solar panels.
Considering that we are getting wind power, or somebody is already produced the solar power and we are buying it from them.
Right. Then the area will be small, because a lot of area is required for solar and wind. But once you get, suppose you buy from somewhere, and then you set up, that plant will be around not a big area, maybe around 5 to 6 acres of land. Around that will be okay. Yeah.
Right. This is considering that the wind power or the solar power is being generated from another unit.
Exactly.
Right.
Yes.
Okay. And is there any specific permissions that they have to get, or just the environmental clearances?
No, here because there is no much pollution.
Right.
Emission in this case, actually, this is pollution-free industry. So environmental clearance will be very less. So not much concern. So we are not emitting any gases.
Right.
Not emitting any gases. Yeah.
And since you will be storing the gases, maybe you will have to get the PESO approvals and things like that.
Yeah, approvals, government approvals, simple approvals are required.
Right.
Yeah, some approval will be needed.
Okay.
Yeah.
Okay, sir. I think it was a very good session with you on these emerging technologies. The key takeaway from this is, although there is a huge potential for green hydrogen and green ammonia and methane, but right now the investments are still on the higher side, and the entrepreneurs, like how you said, they can look at starting small with 100 or 300-ton kind of plants, and try to start manufacturing at a smaller scale, and then as the demand grows, they can look into expanding into bigger plants. As of today,
that is what presently one of the party I visited, they have the same plan, expand later on. Start with a smaller capacity and expand later on. Yeah.
So as of now, the government is the major investor, but as sir mentioned, there are a few schemes as well, which will be coming out, I think, for methanol blending with the diesel. Again, these are not green methanol as such. It is the normal methanol. But government, like how ethanol blending has got very good PR, and we are going for EBP 20 as our fuel, and a lot of PR has happened with the Nitin Gadkari ji, openly proclaiming that very soon we'll be coming up with EBP 35 as well. So although ethanol has progressed very fast, in case of methanol, the progress has been slightly slower. But considering that diesel is used in most of the trucks and buses and the heavy fuel in consumption engines, the diesel generators and like that, so methanol will very surely become a fuel additive
Yes.
very soon. And
Yes.
we have also seen, especially in the Karnataka KSRT and the BMTC, the Karnataka Metro Transport Corporation. So here they have started using about, I think, 130 or 140 buses which run on specifically MDP-15. Basically, it is methanol blended diesel to the tune of 15%. So it's a very good experiment, and I see, the BMTC, KSRTC also trying to emulate the same policy. Once we have a good response from the government and state road transport corporations, obviously the private players will start using such fuels. Although currently only IOCL and I think HP has a few bunks with the MD-15 fuel available. But very recent news is that SR is also trying to look into this for making MDP-15 available. But having said that, methanol definitely has good, I would say, a good opportunity for a new entrepreneur, just like how ethanol has been promoted. But a few government policies have to be tweaked, and we expect very soon in the month of September or October that a new policy for methanol blending will be coming out. If that happens, and if it is anywhere close to what the ethanol blending program is, then I'm sure a lot of entrepreneurs can take advantage of this policy. Because in case of ethanol, all of you might know that 95% of the project cost will be funded by the banks. On ground realities are different, because we ourselves are working on two such plants. About 60 to 70% is being funded, but the good part is 50% interest subvention is being given. And also the government is going to do the buyback of ethanol that you are producing. Similarly, when you are making methanol, the same policies might be coming up, where government will be buying out the government, as in the oil marketing companies, will be buying out the fuel that you are producing. So that could be a very good sign for entrepreneurs to jump into methanol. We definitely expect better policies to start coming into methanol blending as well. As regards to the kind of approvals that are required, typically most of these additives, which are fuel additives, will require EC, that is the environmental clearance, and also maybe the PCB, that is the Pollution Control Board, and if required, maybe from the PESO, because you will be storing some of the fuel additives. So PESO approvals is something that will be looked at. So apart from this, I don't think there are any, radically different approvals that will be required, or anything that could change. But it's definitely a sector that can be looked at. And also, unlike ethanol, which requires investments to the tune of 100 to 120 crores for a 100 KLPD plant, here with methanol, I think the investments will be much lesser. And also, it need not be that you have to go for green methane as of now. You can also look at gray methane, because obviously, India having a good reserve of coal, we can look at gray and other blue methane as options. So I think definitely gives a perspective of how the industry is coming up, what are the potential opportunities, and how anybody interested in it can start off. Of course, a few things are still in gray, but definitely with the right expert and the right kind of people behind you, I think you as an entrepreneur can look at setting up these units. With that, I would like to thank everybody on this session, and also the two speakers for giving us a sneak peek into both the sectors. It was a wonderful session today with both the sessions and four speakers that we had today. Mr. Subhash Patil, and also Dr. Anand for his views, and also trying to answer most of the questions that we have had. At the same time, any questions that any of our audience might have, kindly write into us, and we will share it back to the experts and get their answers. And thanks for being a wonderful audience. And do do be in touch with SolutionBuggy, because we'll also be running another webinar on biofuels and CBG, particularly compressed biogas, on September 8th. So if anybody is interested, then you can register for it. Thank you. Thank you once again to the speakers.
Okay. Thanks.
Thank you, sir. Yeah.
Thank you. Thank you. Thank you.